Okay, good morning and welcome to Math 8. We are going to do a lesson on 3-5, and that would be intervals of increase and decrease today. So if you're in my class, we are in our note packet. We are to almost the very last page in the note packet. So second to the last page, look for this title, Intervals of Increase and Decrease. And we're going to start with some vocabulary. So I'm going to put it up here. If you need a second to pause it, to write it down, feel free to pause the video to write the vocabulary. Basically, what you need to know is that the independent variable is going to be our x value variable, and that's independent of all the other variables. The dependent variable are our y values, and those then depend on the value of the x values. What we're going to talk about today is the interval. So an interval is a period of time between two events or points in time. And then we're going to talk about something called a qualitative graph, which represents the relationship between quantities without numbers today as well. Okay, so again, if you need to pause the video to get the definitions written down, please do it now. All right, we are going to move on. We're going to do the examples, and I'm going to leave the try it for you to do on your own. All right, example 1. An express train reaches its travel speed of 150 miles per hour a short time after leaving the train station and travels at this speed for an extended period of time. What does a qualitative graph of the distance the train travels over time look like? Okay, so in this case, what we want to be able to do is create a graph, and we're not really going to use any numbers, right? Because it doesn't give us a lot to go on. So what we will do is we're going to make our axis. So this is going to look like this, right? And what we want to do is label what we're talking about. So we're talking about time. So as the train travels, we're going to talk about how far it goes, its distance. So we want to label these. So time is going to be our independent variable. And distance is going to be our dependent variable. Because the distance that the train travels is going to be dependent upon how long it travels. Oh, sorry. Okay, so now what we're going to do is just kind of talk about what this means, okay? So there are no numbers, but we know that as time moves on, as we get more time, the train should travel further away. And it says that it's 150 miles per hour a short time after leaving the train station, and then travels at that speed for an extended period of time. So think about what we know about a train. It's not going to start out at 150, right? So at time 0, it's not going anywhere, but it's got to start out where it's going to reach its speed, right? And it goes a little bit of distance. Well, finally, it gets to the 150 miles an hour. And so it's going to start going a little faster, but it's going to stay going that fast. So this little slope has got to be a little bit less, and then it gets a little steeper over time. This is a qualitative graph of this. Now, there are two intervals in this graph that I want to show you. The first interval right here, and I'm going to dot this line, this is the train speeding up. The second interval is the 150 miles an hour for that extended period of time. Okay, let's try again. So you can do the you try it here on your own, and then we're going to do example 2. So example 2, let's try this again. Let's make sure this is on screen real quick. Oh, a little bit higher. All right, example 2. The graph shows the behavior of a ball that a soccer player kicks to a teammate. Describe how the height of the ball and time are related in each interval. Okay, so something that, it depends on the copy you have, that is a little bit hard to see are the labels here. So this says height, and this says time. And this is a soccer guy kicking, and this is another soccer guy kicking. So, and this says interval 1, and I'll just label that. And this says interval 2. So what it's showing here is this guy is kicking the soccer ball, and so what you can't probably see and need to write in, over to this guy right there. And it's making like this rainbow shape. Okay, and so this is the soccer ball right here. If you can't see it, there's the ball. And so we want to describe how the height of the ball and the time are related in each interval. So in interval 1, let's split this up. In interval 1, the function is increasing, we say, because he kicks it, right? So in interval 1, the function is increasing. And I'll make that sure that's a 1. Because as time increases, so does the ball. So we'll say because as time increases, so does the ball. The height of the ball. The height of the ball. Okay, so this is pretty easy, right? When you look at this picture, this guy kicks it, and so to do the qualitative graph in interval 1, it's increasing because as the time increases going this way, the height of the ball increases. Well, then it hits its maximum height, and then we're into interval 2. So interval 2 is really easy. What's happening there? In interval 2, and hopefully I can get this on screen here. Let me see if I can maybe zoom out a second so that you can see what I'm writing. In interval 2, and I am going to abbreviate here, the function, what is the function doing in interval 2? In interval 2, the function is decreasing. And why is it decreasing? How do we know that? If you look at it, what's happening? So we start here, the function is decreasing because as time now is still increasing, we're going this way on time, the height of the ball is also decreasing. As time decreases, or increases, I'm sorry, not decreases, as time increases, as that keeps going on, the height of the ball decreases. So describing these is really just a matter of looking at the picture and telling what's going on. It's pretty obvious as you get going. These are pretty easy ones. You can use your intuition to help you. All right, last one, so you can flip the page here. On the back, and I'll re-zoom in so you can see a little bit better. The last one for our intervals today is this one. It says label the intervals. And which interval is the function increasing, decreasing, or constant? Choose labels. That got cut off. Choose labels for the independent and dependent variables, and then write a scenario that this graph could represent this time. Okay, so let's take a look at what we've got here. Okay, so we've got the intervals are already labeled on here, so let's talk about that first. So interval 1 is labeled right here. This is interval 1. So we'll talk about that. Interval 1, what is it doing? It's flat. So we say that that is constant. Okay, let's talk about interval 2. That's this one. Well, it's going down. So interval 2 is decreasing. All right, interval 3. Pretty obvious, right? It's going back up. Interval 3 is increasing. And for the rest of them, we'll use C, D, or I. Now, interval 4 does change, right? But it is still going up. So interval 4 is also increasing. Okay, how about interval 5? Interval 5 again is flat. So that means interval 5 is constant. And finally, interval 6 is sliding down a little bit. And so that would be decreasing. That's pretty easy. Okay, the harder part is to make up our own scenario now. So in this case, right, what could be happening here? And what could we label these sorts of things? Well, let's talk about what this could be. So maybe this could be, I don't know, maybe a ride at a theme park, right? A roller coaster of some sort. It would be starting at a constant and then do a dip and then it goes up the hill and then constant again and then back down. So if that were the case, right, what would be our independent and dependent variables? Well, we could say our independent variable then is time. And so what this would represent if this were a roller coaster would be the height of the roller coaster. Right? And so you do this ride. It would be a little bit jagged, I guess. So maybe a roller coaster isn't the best scenario, but maybe you could come up with a different one. Okay, so we'll stick with it for now. So it says, then write the scenario that the graph could represent. So you would say the scenario could be a roller coaster riding over time. All right, and maybe you can come up with a better one than I've come up with, so that, because that would be a pretty jagged roller coaster. Okay, that's it really for intervals and for talking about how they're increasing, decreasing, and independent and dependent variables. If you have any questions, please feel free to email me and I'll get back to you as soon as I can.